So in the last class we have seen 8 marks question. So now we will see 10 marks question. So starting with, so I'm sharing the screen. I hope it is visible to you. Explain the planning stages in subsurface exploration program. So what are the planning stages that are available in a subsurface exploration program? So the subsurface exploration is generally carried out in three stages. Number one, reconnaissance. Number two, preliminary investigation. Number three, detailed exploration. So number one is reconnaissance. It includes a visit to the site and study of maps and other relevant record. So what is subsurface exploration? Subsurface exploration generally carried out in three stages. Number one is reconnaissance. So what is reconnaissance? It includes a visit to the site and study of maps and other relevant records. So what is included in reconnaissance? It includes a visit to the site and study of maps and other relevant records. It helps in deciding future program of site investigation, scope of work, methods of exploration to be adopted. Next is preliminary investigation to determine the depth, thickness, composition of each soil strata. The depth of rock and water table also determined. So in preliminary investigation, what we are doing, we are determining the depth, thickness, composition of each soil strata. So the depth of rock and water table is also determined. So the geophysical method also used for location of boundaries of different strata. Detailed exploration to determine the engineering properties of soil in different strata. It includes extensive boring program, sampling, test of soil samples on labs and field at natural state. Now, establish location of water table in clay strata. Water in a borehole is spilled out at a depth of 10.67 meter below ground level. A rise of water was observed at 24-hour interval as follows. H1 is equal to 64 centimeter, H2 equal to 57.9 centimeter, H3 equal to 54.8 centimeter. So your H naught is equal to H1 square divided by H1 minus H2. So H1 square is nothing but 0.64 square. H1 minus H2 is 0.64 minus 0.579. So your H naught is equal to 6.714 meter. Or your H2 is equal to H2 square divided by H1 minus H2. Or H2 is 0.579 square divided by 0.64 minus 0.57. So your H2 comes out to be 5.496 meter. And H3 is H3 square minus H2 minus H3. So it comes out to be 0.548 square divided by 0.579 minus 0.549, or H3 is equal to 10.01 meter, or HW is equal to HW minus H naught, or 10.67 6.714 equal to 3.956 meter, or HW is equal to HW minus H1 minus H2. Yes, there was a technical issue. Sorry for the inconvenience caused. So where did we stop? Definitely this. I'm sharing the screen. Hope it is visible to you. So it's soft, normally consolidated clay layer, 18 thick. The natural water content, saturated unit weight, specific gravity, liquid limit are 45%, 18 kilo Newton per meter cube, 2.7 and 63% respectively. The vertical stress increment at the center of the clay layer due to foundation load is 9 kilonewton per meter square. The ground level is at the surface of clay layer. Determine the settlement of the foundation. So what you have to do, you have to determine the settlement of the foundation. H is equal to 18 meter, Wn is equal to 45% or 4.45. Gamma saturated is equal to 18 kilonewton per meter cube. G is equal to 2.7, whereas liquid limit is 63%. Next, delta delta C is equal to 9 kilonewton per meter cube. SP is equal to how much? So SP is equal to H into CC 1 plus E log to the base 10 sigma I plus delta sigma divided by sigma I. CC equal to 0.009 into LL minus 10. It comes out to be 0.009. 6.3 minus 10. So it comes out to be 0.477. EI is equal to G into WN 2.7 into 0.45. It comes out to be 1.215. Sigma I is equal to gamma subtracted to h by 2. 18 into 18 by 2. It comes out to be 162 kilonewton per meter square. Next is sigma I plus delta Sigma equal to 162 plus 9. It comes out to be 171 kilonewton per meter square. Therefore, SP equal to 18 into 0.477 divided by 1 plus 1.215. Log to the base 10 divided into 171 by 162. So it comes out to be 0.091 meter or 91.02 meter. So business using business theory, construct isobar of intensity 0.25 Q, 25% of isobar, where Q is point load acting on the surface. Isobar of intensity 0.25 Q. Sigma Z equal to 0.25 Q. So using business equation under point load, sigma Z is equal to Kb into Q by Z square. So here Kb is equal to 3.25 into 1 divided by 1 plus R by 2 square by 5 by 2. Therefore, your Kb equal to sigma Z into z square by q or 0.25 q into z square by q. It comes out to be 0.25 z square. The number of numerical values of z are selected and the value of kb, the values r are calculated. The depth at which the isobar sigma z is equal to 0.25 q, the depth at which the isobar sigma z is equal to 0.25 q. Process the excess of loading is calculated by kb when r is equal to 0. This r is equal to 0, kb equal to 3 by 2 pi into the bracket 1 divided by 1 plus 0 by 2 square 5 by 2. kb equal to 0.4775. So equation 1 becomes 0.4775 is equal to 0.25 into z square, or z is equal to under root of 0.4775 by 0.25. It comes out to be 1.38 units, or z units equal to kb equal to 0.25 into z square, R is equal to under root of 3 by 2 pi by kb, 2 by 5 minus 1 units. 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.38. So these are the values obtained. Module 3. Write a critical note on Taylor's stability number. The total cohesive force is proportional to the cohesion C and height of the slope H. The force causing instability is the weight of which W is proportional to the gamma, and H is IFC's factor of safety with respect to cohesion. So FC equal to CH by gamma H square, FC equal to C by gamma H. Therefore, SN is equal to C by FC into gamma H. The dimensional quantity C by FC into gamma H is called Taylor's stability number, SN, and this can be calculated from FC itself analytically. FL is equal to FC by CM, therefore SN is equal to CM by gamma H. Further, FC equal to FH equal to HC by H, or FC by H equal to HC, or HC is the critical depth of slope. Taylor's stability number Sn is based on factor of safety with respect to cohesion Fc. In the case where F factor of safety is applicable to both cohesion and friction, Tm is equal to Tf by F equal to C by F plus sigma tan phi by F. Tan phi m equal to tan phi by m. Therefore, phi m is equal to tan inverse of tan phi by F. Taylor also determines stability number for different values of slope, angle, beta, and depth factor df. The depth factor df is defined as the ratio of the depth to hard strata below top of slope to the height of the slope. Explain the causes for slope failure and also list the types of slope failure. The failure of earth slope takes place mainly due to the action of gravitational force, seepage forces within the soil mass, erosion of the surface of slope due to flowing water, sudden lowering of water adjacent to a slope, force due to earthquake, force due to earthquake, type of slope failure, infinite slope, rotational slope failure, translation slope failure, compound slope failure. So finite slope, intimate slope failure, a phase failure, toe failure, or base failure. Now model 5. A street footing 1.25 meter wide is located at a depth of 1.5 meter in a non-cohesive soil deposit for which n values of SPT is 20. Water table is located at a depth of 2 meter below the ground surface. Find the allowable bearing pressure for this site. Tarzan is empirical relation, so QP is equal to 35 into n minus 3 B plus 0.3 divided by 2B RW2 into RD kilonewton per square. Here RW is 2 is equal to 0.5. 1 plus ZW2 by B equal to 0.5 into 1 plus 0.5 by 2. So here RW2 comes out to be 0.7. RD is equal to 1 plus 0.2 into T by B less than equal to 1.2. RD equal to 1 plus 0.2 into 1.5 by 1.2 equal to 1.25 less than equal to 1.2. Hence take RD equal to 1.2. RP equal to 35 into 20 minus 3 into 1.2 plus 0.3 divided by 2 into 1.2 square into 0.7 into 1.2. So RP comes up to be 190 kilonewton square. Mehra's equation QP is equal to 5 by 4 N into RW into RD tons per meter square. RD is equal to 1 plus 0.33 into D by P less than equal to 1.33. So your QP is equal to 5 by 4 into 20 into 0.7 into 1.33. So it comes out to 23.6 ton per meter square. QP is equal to 231.6 kilometer square. Determine the bearing capacity of soil by using standard penetration test as per IS 213 guideline. Standard penetration test employs a split sperm sample which consists of a driving shoe, a split barrel of circular person which is longitudinally split into two parts and a coupling. This is the rammer of 65 centimeter drop, 75 kg, borehole, split sperm sample, 15 centimeter, 15 sample, and equivalent plus q. Standard penetration test employs a split sperm sample which consists of a driving shoe, a a split sperm sample of circular fraction which is longitudinally split into two parts and a coupling. A borehole is advanced to the required depth and the bottom is clear. A spoonful sample is driven into the cell for a distance of 45 centimeters by blows or drop a height of 65 kg falling vertically and free from a height of 675 centimeters. The number of blows required for the last 30 centimeter penetration is added together and recorded as the n values at the particular depth of the borehole. The split spoon sample is disconnected from the driving shoe and the coupling. The soil sample collected inside the spoon is carefully collected so as to preserve the natural moisture content and transported to the lab for test. Design charts for soil foundation, resting equations are developed on the basis of n values. Knowing the values of n, 5 value read from the chart. Sigma NF equal to sigma 1 NQ minus 1 SQ by Q IQ plus 0.5 gamma B the N gamma D gamma I gamma W comma. So list and explain the classification of piles based on material composition. The piles are classified into four types based on material composition: timber piles, steel piles, concrete piles, and composite pile. So timber piles are nothing but these are the piles made up of good quality of timber. They are subjected to damage by hard driving and should not be driven through hard start or boulder. The maximum design load is about 250 kilonewton. Steel piles. Steel piles may carry loads up to 1,000 kilograms more. The cost of steel pipe is also very high. Concrete pipe. The concrete pipes are two pipes, namely precast concrete pipe and cast in situ concrete pipe. The precast concrete pipes are used for maximum design load of 800 kN, and cast in situ pipes are designed for maximum of 750 kN. Next come composite piles. The composite piles may be of either concrete and timber or concrete and steel. These are suitable when the upper part of the pile is project above water table. Question number 10. Explain in detail the principle associated with determination of pile load capacity using static formula. The shapes of various surfaces at the tips of the pile accordingly receive only punching shell with a percent deep foundation irrespective of the density of the soil's depth with the ratio. C bed is greater than 4. The total failure load QU bar is equal to Q bar plus WP. QU bar is equal to Q plus WP with the net ultimate load is in excess of the overburden pressure Q naught AB I delta. QU bar equal to Q naught A naught equal to QU plus WP minus Q naught into AB. QU bar is equal to QB plus QF plus WP minus Q naught into AB. For all practical purposes, WP is less than equal to Q naught into AB. QU equal to QB plus QF, where QB is the total base load of coil, Q is the total skill load, Q naught is the effective overload pressure at the base level of coil, WP is the weight of coil, AB is the sectional area of pipe at the base level. The general equation for the base resultant is QB for psi coil. Soil may be written as QB equal to CNC plus Q naught NQ plus half gamma D N bar into AB. C is the effective unit cohesion, gamma is the effective unit of soil, Q is the effective overburden pressure at the base level of coil gamma L, and C and Q N bar is the bearing capacity factors, L is the depth of amendment of coil. The term half gamma D and gamma becomes insignificant and normally neglected. Therefore, QB is equal to CNC plus Q naught NQ into AB. or for a purely cohesive soil, C is equal to 0, QB is equal to Q naught into NQ to B. For a purely cohesive soil, Q is equal to 0, phi is equal to 0. QB equal to C into NC into AB. Here C is 100 shear strength of pillar at the base level. The general equation for shaft resistance Q may be written as Q is equal to Fs into AS, where Fs is the area shaft resistance, AS is the shaft area for which Fs is applicable. For a pile in cohesion soil, C is equal to 0. QF may be written as QF is equal to Fs into AS equal to Q naught Ks T and AS. For piles in cohesive soil, phi equal to 0. QF equal to FSAS into 2CUAS, where Q naught equal to average overburden pressure over the embedded depth of for which EST and rho is applicable. E is equal to lateral stress coefficient, gamma equal to angle of wall friction, C equal to average untrained shear strength of while alpha is the adhesion factor. If Fs varies along the shaft for a cohesion cell, Q equal to P into sigma 0 to the pi Q naught Ks tan alpha. For a cohesive cell, Q is equal to P sigma alpha, where P is the parameter of coil, delta is the thickness of it for which Q naught equal to A is 25. So this completes our applied geotechnical engineering question bank. I hope you have understood. If you have any doubt, you can just drop a message in the comment box. If you have any queries regarding the question bank, 2 marks, 8 marks, 10 marks, you can just drop a message, or you can email me at nadim@qn.university, or you can just give me a call at 8553171859. I hope you have understood the concept. In the next class, we will in the next class we will discuss with another topic. Thank you, friends. I hope you have a good night. So I'm ending the meeting.